We now look at some examples of how we find the radius of convergence. And we're just looking for the radius right now. We're not worried about the interval. So in the first example, I want to find the radius of convergence for the power series and the sum going from n is equal to 0 to infinity of n factorial x to the n. Our main tool is going to be the ratio test. And so I apply the ratio test to this as follows. I do the limit as n goes to infinity of the absolute value of n plus 1 factorial times x to the n plus 1. Remember, we are checking the next term compared to the previous term. All divided by n factorial x to the n. Splitting up the x to the n plus 1, we will end up now with the limit as n goes to infinity of the absolute value of n plus 1 times n factorial, all times x to the n times x in order to get x to the n plus 1, divided by n factorial times x to the n. And we see that the x to the n's are going to cancel out. The n factorials are going to cancel out. And so this is going to be now the limit as n goes to infinity of the absolute value of n plus 1 times x. Now the limit is only dependent upon the x value, and so I can pull the absolute value of x across the limit, and I'll get the limit as n approaches infinity times n plus 1. And we know that that limit is going to be infinite, so we're going to get the absolute value of x times infinity, which means this is going to be infinite. And this is never, sorry, other way around, this is never less than 1. This is never less than 1, except for when x is equal to 0. And so since the limit is going to be infinite, this means that the only value of x for which the series converges, the power series, is x is equal to 0. So the radius in this case is going to equal 0 because the limit is going to be infinite. Remember that when we do try to solve this, if we were to try to solve the inequality up above, you would have ended up with the absolute value of x less than 1 over infinity, which would have given you the radius of convergence being 0. Let's try another example. So the radius in this case is r is equal to 0, which means it only converges at a point. In our next example, we are not centered precisely at 0, we are centered at 2. And what we're interested in right now is just the radius. How far from the center do we have to go in order for us to get convergence? So we use the ratio test again. That is our main tool in this case. So we do the limit as n goes to infinity of the absolute value of 3 times x minus 2 to the n plus 1 all over 3 times x minus 2 to the n. This is going to be the limit now as n goes to infinity the 3's, of course, are going to cancel out, of the absolute value of x minus 2 to the n times x minus 2 all over x minus 2. And we can cancel out the x minus 2's. Sorry, I canceled out the wrong things. We can cancel out the x minus 2 to the n's, leaving us with the limit as n goes to infinity of the absolute value of x minus 2. There is no n in this problem, so we don't have to worry about it. So this limit is going to just be the limit as x. The limit is going to just equal the absolute value of x minus 2. And in order for us to get convergence, this limit has to be less than 0, less than 1. Now, we don't have to solve this inequality because all we're looking for is how far from the center we have to go, and it already tells us that. This here is going to be the r. Ostensibly, what this means, if you were to look on a number line centered at 2, we would go out 1 and to the left 1 in order for us to get convergence. So your r, or your radius of convergence, in this case would be r is equal to 1, would be the distance from the center that you would have to travel in order to get convergence. You could assume that the domain of the function is from 1 to 3, but except possibly at the endpoints, which we still have to verify. And let's look at one more example at finding the radius of convergence. We're just interested in the radius, not the interval right now. So this is a power series that is centered at x is equal to 0. And just to remind you what these power series actually are, just to remind you for a moment, because I just did 2 examples and we didn't actually talk about what they are. You should try to write out the first few terms of it in order to make sure you understand. When n is equal to 0, you're going to get 1. Sorry, when n is equal to 0, you're not going to get 1, you're going to get x. Because when you put 0 in for n, you'll get x to the 1. And you put 0 in here, this will become 1, and this will become 1 also. The next term will be minus x cubed over 3 factorial, plus x to the 5th over 5 factorial, minus x to the 7th over 7 factorial, and it continues indefinitely in that vein. And we want to determine the values of x for which this is going to converge. So our main tool is the ratio test. We do the limit as n goes to infinity of the absolute value of -1 to the n plus 1, all times x to the, now wherever you see an n, replace it with n plus 1. So this becomes 2 times n plus 1 plus 1, all over 2 times n plus 1 plus 1, the quantity factorial, all divided by -1 to the n, x to the 2n plus 1, all over 2n plus 1 factorial. This is going to equal the limit as n goes to infinity of the absolute value of, now we know the -1 to the n plus 1 and the -1 to the n is just going to yield a -1. And we'll get x to the 2n plus 3 all over 2n plus 3 factorial times 2n plus 1 factorial, all divided by x to the 2n plus 1. This is going to equal now the limit as n approaches infinity. The absolute value is going to annihilate the -1, and so you'll end up with the absolute value of x to the 2n plus, well, let's say x to the 2n times x cubed, all over, now the 2n plus 3 factorial is going to be 2n plus 3 times 2n plus 2 times 2n plus 1 factorial. Remember, we go down by 1 value each time. And this will be multiplied by 2n plus 1 factorial over x to the 2n times x. Whereby the 2n plus 1 factorials will cancel out. The x to the 2n's will cancel out. we'll cancel out a power of 3 and end up with a 2. And so this is going to come out to be the limit as n approaches infinity of the absolute value of x squared all over 2n plus 3 times 2n plus 2. Now, x squared is always a positive number, which means we can pull it out and we don't need the absolute values. And our sequence is also always positive, and we see that it goes to 0, which is always less than 1. And so this implies, since the limit is always less than 1, regardless of the value of x, that our radius of convergence is infinity.